In this lecture, we are going to remove the camera from the player, then set up the camera again in a completely different way. Just like I mentioned before, the camera we added in the player blueprint was just an easy and quick way to make it work. But for the needs of our game, we're going to have to set up the camera differently. And in this lecture, we're going to spend quite some time doing this because the setup is indeed more complicated. But after we put this off, and in the later lectures, you're going to see why this is necessary. All right, first, let's open the player blueprint to remove the camera inside. I'm going to select both the arm and the camera components. Then we delete them altogether. All right, now let's run the game to test. Without the camera component, the engine just created a default camera for us that's pointing forward. Let's stop the test. Now let's create a new camera blueprint class. Open the content drawer. In the BP folder under the game folder, let's create a new blueprint class. This time, let's search for the camera actor. This is a pre-made class that comes with the engine, and we can make use of it. Let's rename it to BP_camera. Let me save all of the new files first. Then we go back to the content drawer and drag the BP camera into our world. Notice that the camera looks flat in the viewport. This is actually good because I'm in the elite mode in the editor, so the camera is not affected by any light. In the contrary, if you go to the lit mode, then the camera is going to become completely black because we don't have any light sources here in the game, since this is just a 2D game and we don't really need them. One thing I want to emphasize again is that I'm probably going to stay in the elite mode in the editor most of the time throughout this course. And that's the best mode for us to view the pixel art of the sprites. Right now, you might also notice that the camera is facing the right direction. So it might look like rotating the camera to make it face the platform is a good idea. So basically, you can just rotate the camera here by minus 90 degrees. But personally, I think it's not a good idea to do it here because we might forget about where we rotated the camera later on. And I feel like if we're gonna do it, we should do it inside the camera blueprint class. So let's go open BP camera. Then we can select the camera component and change its Y rotation to 90 degrees. Let's compile and close this window. Now we can see the rotation of the camera is updated because the change we just made inside the blueprint class. Now the camera is too close to the platform. So let's move it back a little bit. The exact position of the camera also doesn't matter here because we are going to make the camera follow the player later on. There is one more thing we need to change in the camera blueprint. Let's bring up the content drawer again. Go to the BP camera. Select the camera component. We want to set the projection mode from perspective to orthographic. This is very, very important. The orthographic mode removes perspective from the camera, so the size of the pixel art is accurate. On the contrary, if you use the perspective mode here, the size of the pixel art is going to change based on how far away it's from the camera, and that is not what we want. The orthographic mode also provides other benefits to our game. I'll point it out later on. For now, let's set it to orthographic. Then I want to change the width to 550. This is the number I found out that works with my monitor the best. Now you can get a sense of how the pixel art looks in the preview window in the bottom right corner. This preview window only shows up when the camera is selected. Now the size of the pixel art does not change anymore when we move the camera back and forth. And if you do want to make things look bigger or smaller, you need to change the width of the camera in the BP camera. Alright, now we have the camera set, but what do you think is going to happen when we run the game now? See, we are not using this camera. The engine still created a new camera that points to the forward of the player. And the BP camera we just added into the world is just not in use. Let's hit the F8 key to detach. And we don't even see the camera we just added into the world. But we can select it in the outliner, and we can see it's still here in the world. It's just the model of the camera is hidden when the game runs. And this is a good time to point out that many things we can see in the editor will become hidden in the game. For those things, if you want to see them in the game, like the hidden camera here, you can go to the details panel. You can search for the keyword hidden or hide, and you're going to see an option that says something is hidden in game. If you disable it, the object is going to show up in the game. But of course, we don't need to do that here. I'm just showing you that you have the option here. Let's just leave this option enabled and go back. To actually make the game use the camera, we need to go to the Game Manager Blueprint class we created. So let's go to the BP folder and open BP My Game Manager. We need to tell the game to use the camera in the event begin play. So first, we need to get the BP camera, right? There is a handy function called get all actors of class. For the class, we choose the BP camera, which is the blueprint class we created. This function is going to try to find all of the instances of the class, so the result could be more than one. That's why the output here is an array. An array is just a list of the objects, but usually the type of the objects are going to be the same. So here, we know that we only have one BP camera in the game, so we can get the first member of the array. Just drag out from alt actors, then use the get function under array. The index number is going to be 0 here. This means we are going to get the first member in the array. This is very common because in programming, the first index always starts with 0, not 1. Next, we want to store the BP camera we just found in a variable for later use, because we need to access to this BP camera more than once in this event graph. To do it, right-click on the output and select Promote to Variable. You can see a new variable is created on the left side. Let's give it a name called Main Camera. Also notice that the type to the right automatically set to BP camera. Also, a new set node is added into the event graph, but we have to connect it into the control flow. Otherwise, the set action is not going to happen. To recap, when the game starts, we get all possible actors that is a BP camera. Then we get the first member from the result array, and we store that in a variable called a main camera, and that's it. All right, before we do anything else, let's make sure this is working. I'm just going to use the print function and connect the set function to it. Connect the output of the set function, which is the main camera variable itself, to the in-string input of the print node. This is going to print out the name of the BP camera that is stored in the variable main camera. All right, let's run the game to test. Great, we do have the correct name here in the upper left corner. It disappears very soon, but we got it. We can remove the nodes to print out the message. Next, we need to tell the engine to use this camera. Let's call the getPlayerController function first. This function is going to give us the controller that's controlling the player, and the index 0 is the first player. Since we only have one player in the game, this should give us the correct player controller. Then we call the setViewTargetWithBlend function on the player controller. This is a function that belongs to the player controller. That's why we needed to get the player controller in the first place. It's going to set a camera as the active camera for the player. So let's bring in our main camera. Then we plug it into the new view target input. Now let's connect the set function to it. This function can also create a blend animation, so the camera view moves from one place to another. But we don't need that, so we're just gonna leave the blend time to 0. Alright, let's run the game to test. Great, the camera is indeed in use. But for now, it doesn't follow the player. So next, let's make it do that. Let's go to the content drawer and open the BP camera. I'm going to add two variables on the left side. The first one is called player actor. This is going to be the player in the world that we want this camera to follow. For now, the type is Boolean, which is wrong. We know that the class of the player is BP player, but we do not need to set the type to BP player here. To be honest, setting the type to BP player is alright. It should work here, no problem. But we just do not need access to all of the functions in the BP player class. What we only need here is the location of the player. So I'm just gonna set it to actor. This is under the object types because our BP player is inherited from the 2D paper actor class, which is essentially inherited from the actor class. Next, we need another variable to hold the offset of the location of the camera from the player. So the camera is always in a fixed distance from the player, and that makes it look like the camera is following the player. We're going to call this variable offset. For the type, we set it to vector. A vector can store the data for the x, y, and z for the offset. We need to set the default value for the offset, but we need to compile the blueprint first. We can only set the default value on the right side after the blueprint is compiled. I'm just going to set it to 0, 170. This is the value that I found that works best. Please notice that the z value here is 70. It's going to shift the camera upward, so the player is not at the center of the screen. This is a typical camera position for 2D games because it allows you to see more of the world above instead of having the ground fill up the lower half of the screen. Next, we have to get the BP player from the world and have the player actor variable hold on to it. We are not going to do it here in the BP camera. Instead, let's make sure this blueprint is compiled, then go to My Game Manager. We can do it here in the event begin play. So after we set the view target here, we can get the BP player that's being controlled directly from the player controller here. We can use the function getControlledPawn. After all, the controller of course knows the character that is controlling, right? So this is going to be our BP player that's being controlled. Then we can drag in the main camera variable and set the player character variable we just created on it. Keep in mind that you can only find the player actor variable here after the BP camera blueprint is compiled. Now let's set the player actor to the return value of the getControlledPawn function. And we also need to connect the control flow. Alright, let me rearrange some of the nodes here to make the graph clear, and we can review what is happening here. So after we set the view target, which is going to make the camera active for the player, we get the BP player that's being controlled from the player controller. Then we set it to the player actor variable in the BP camera. Alright, go back to the BP camera. To make the camera follow the player, we need to update the location of the camera every frame. So we're going to do this in the event tick because this event is going to be called every frame. Before we start working on the camera, we want to check if the player actor gets the BP player in the world. So let's drag in the player actor. We call the its value branch on it. Be aware that the one we need is this one that has a question mark in front of it. This is going to give you a branch. It's valid means we do have something in the player actor. Otherwise, for the it's not valid case, that means the player character is null and we don't have the BP player in it. To check if this is working, let's use the printString function. Connect isValid to the print function. Then connect the player actor to the print function. Alright, let's test. Looks good. We get the BP player in the camera. Now we can delete the note for the printout message. Then we get the actor location from the player actor. So this is the world location of the player that we are controlling. And we need to add the offset to this location. So we use the add function. Then we drag in and hook up the offset. This is going to give us the final location of the camera. So we drag out the return value and call the setActorLocation function. This way, the camera location is automatically connected to the new location input of the function. And the target is self, which is the BP camera itself. We don't need to change it, just connect the flow. We can leave another two options in the function disabled, since we don't need them. Now let's compile and test the game. Looks good. Now the camera is following the player everywhere. We have pretty much finished the job here, but I think we should smooth the movement of the camera here. Now it's hard locked onto the player, but it's gonna look more natural with a little bit delay in the movement. So the camera takes a little bit time catching up with the player. So next, let's lerp the position of the camera. This is a very common technique to make the movement of the objects look better. Let's get the current location of the camera first. We can do it with the getActorLocation function. Notice the target itself which is the camera. Then we drag out the return value and call the lerp function. Then we plug the new location for the camera in the B input. So the lerp function is going to give us a new location that's in between the current camera location and the new camera location. And the calculation depends on the alpha input. So let's plug in the result to the new location input. Next, for the alpha input of the lerp node, we need to plug in the delta time of the event tick function. All right, let's just connect it and reroute this connection line. So how fast the camera moves to the new location is based on the value that we plug into the alpha. If you want to make the movement slower, you can divide the delta time by a big number first. On the other hand, multiplying the delta time by a big number is going to make the movement faster. For now, let's just compile the blueprint and test the game. Alright, now we can see that the camera takes some time catching up with the player. And for me, the movement is a little bit too slow. So let's just modify the delta time first. We want to make the movement faster. So let's multiply the delta time by 100. Then we reconnect the line. Alright, let's run the game to test again. Now the camera is moving too fast, so we don't feel the delay in the movement anymore. So after this test, I spent some time trying to find the correct value, and the number that works best for me is 10. Alright, this works pretty good for me. But you might notice that when the game starts, there was a rapid movement in the camera. That's because the camera is too far away from the player when the game starts. Of course, you can just simply place the camera close to the start point to solve this problem. But I'm thinking about some other solutions just for fun. Otherwise, having to place the camera at the start position of the player in every level could become a tedious job. So my first solution is to reuse these nodes and connect them to the event begin play. This is going to calculate the correct position for the camera right after the game starts. Then we're going to set the location of the camera. So basically, I just want to force the camera to move to the correct location when the game starts. Let's test the game. Unfortunately, it does not work. The rapid camera movement still happens, which means the nodes here are not working. I think the problem is that when the game starts, the player actor is still invalid. We can print out a message to test my theory. Right, we can see that it is invalid when the game starts. This is because we set the player actor to the BP player in the event begin play in the game manager. But it seems like the event begin play in the BP camera happens first, before the event begin play in the game manager. That's why the player actor is still invalid at the moment. So I have to abort this solution and delete the nodes. Let's try something new. Maybe we can pack everything we are doing in the event tick into a function. Then we can call this function in the game manager when the game starts to relocate the camera. So let's select all of the nodes here. Right-click and select collapse to function. I'm going to call the function update camera position. Notice that the new function is still keeping the delta input, which is handy for us. Let me reconnect the delta. Let's double-click on the function to get into it. And we want to update the name of the input here. Let's just call it delta. Then let's add a new Boolean input called lerp. And we can use this input to decide if we want to lerp the camera's movement or not. So let's make a branch based on the lerp input. I'm going to put this branch after the first branch, where we check if the player actor is valid, because it has to be valid first, right? Then we connect true to the existing setActorLocation function. Then let's copy and paste this one again, and connect false to it. But this time, we give it the new location before the lerp. So in this case, the camera is going to teleport to the new location instantly. Alright, I think that's it. Let me just reroute this connection to make it easy to see what's going on here. Also, maybe we want to comment some of the nodes. Let's say these 3 nodes are going to move the camera with lerp. And this one moves the camera without lerp. Alright, that's pretty much it. One thing that's very important, we need to go back to the event graph and we want to enable the lerp option. Let me test the game now to make sure we didn't break anything. Looks good. The camera is still following the player with a delayed movement. Next, let's go to BP My Game Manager. After we set the player actor variable in the BP camera, we can call the update camera position function we just created. This is going to force the camera to move to the correct location when the game starts. We can keep the delta time as 0 since we are not going to lerp here. Also, we must keep lerp unchecked. This is going to make the movement instant. Alright, let's compile the game and test. Looks good. Now the camera doesn't shift when the game starts. Alright, one last thing I want to point out before we wrap up. Let's go to the update camera position function. I just want you to know that you can give the lerp input a default value. This way, you can make the lerp option enabled by default. But of course, if you choose to do that, you need to double check that when we call this function in the game manager, the lerp option is disabled. Alright, that's it for this lecture.